Let's see, chat's a little bumping. Absolute values for the DX and DOI will make only northeast and southwest lines, even if the antennas are aligned the other way, I think. Maybe I should have read your message earlier. I wonder if that's what I'm dealing with. Day 8, Resonant Collinearity. That's a fun word. You find yourselves on the roof of a top secret Easter Bunny installation. While the historians do their thing, you take a look at the familiar huge antenna. Much to your surprise, it seems to have been reconfigured to emit a signal that makes people 0.1% more likely to buy Easter Bunny brand imitation mediocre chocolate as a Christmas gift. Unthinkable. So true. Scanning across the city, you find that there are actually many such antennas. Each antenna is tuned to a specific frequency, indicated by a single lowercase letter, uppercase letter, or digit. Okay. You create a map, your puzzle input, of these antennas. For example, okay, so we have these antennas A, and we have these antennas 0. Okay, so uppercase, lowercase, and numbers. Easy enough. The signal only applies its nefarious effect at specific antinodes. I've heard that word once. Based on the resonant frequencies of the antennas. In particular, an antinode occurs... Antinode? I'm going to say antinode. Occurs at any point that is perfectly in line with the two antennas of the same frequency, but only when one of the antennas is twice as far away as the other. Okay, this means that for any pair of antenna with the same frequency, there are two antinodes, one on either side of them. So for these two antennas with the frequency A, they create two antinodes marked with a pound sign. Oh, okay, I see. You can draw like a diagonal here. Oh, that's easy to intuit and probably difficult to program. You have to figure out the distance between these two. So from like left to right, whatever that distance is, you need to go that distance again to get down here, and then vice versa. Okay, I see how to conceptualize this. Adding a third antenna with the same frequency creates several more antinodes. It would ideally add 4 antinodes, but 2 are off the right side of the map. Oh, okay, cool. So instead it only adds 2. Okay, yeah, I see. You basically just draw a line between any 2 of the things, and you get the ones after it. Okay, so if we were to have 4 of these... okay, so we're going to exponentially grow the number of antinodes. All right, I'll have to think about how to actually store this data. But so far, this makes sense. All right. Antennas with different frequencies don't create antinodes. A and A, uppercase A and lowercase a, count as different frequencies. However, antinodes can occur at locations that contain antennas. Okay, in this diagram, the lone antenna with a frequency capital A creates no antinodes, but has a lowercase a frequency antinode at its locations. Okay, I see. So this one would create an antinode up here, and also down here, even though this one doesn't create anything on its own. So we're going to have to store multiple pieces of information in this XY grid, or create multiple grids, like we'll have like a grid of antinodes and a grid of antennas. I'm mixing implementation understanding here. I should stop doing that. The first example has antennas with 2 different frequencies, so the antinodes they create look like this, plus an antinode overlapping the topmost A frequency antenna. Okay, so there'd be an antinode here as well. Okay. I'm following this. I see how they're connected. What causes this one? Where are you caused by? I see it. Okay, I see what causes that one. Okay. I can visually understand what's happening. Oh, wow, that's the end of the words. Okay. Because of the topmost A frequency antenna that overlaps with a 0 frequency antinode, there are 14 total unique locations that contain an antinode within the bounds of the map. Oh, okay. How many unique locations? So we don't need to count the number of antinodes that are generated. If 2 antinodes end up in the same location, it doesn't matter. They're still an antinode. So we just need a frequency count of how many XY coordinates within the bounds are antinodes. Okay, yeah. And this, I'm going to stop saying this seems easy. But at least I understand completely how to approach this problem. So let's go start approaching this problem. Where are we? Cool. What is this? Day 08. CD into that. Cool. Vim example input.txt. And I think I'm going to take this example input and I'm going to filter out the pound signs. And the reason I'm going to do that is because we have to generate those. Those aren't going to be given to us. So let's just go through and turn the pound signs into what periods? There we go. So now we just have this example input, and we know that the number of unique locations that have an antinode from this are 14. The cool thing is I think we can derive that number. Is it 3 to the 2? We have 3 of A and 4. I don't know. Whatever. Let's not even worry about it right now. I'm going to get the real input from the website as well. So let's see what we have. Look at the example input. Here we are. So let's make part 1. Cool. So now we have an executable bash script. What's the first thing we should do? Probably read in the puzzle, right? Done. And this will read it from standard in, so we can just cat example, pipe it into part 1, and hey, that works. I love that bat tool. Yo, me too. Bat is super nice. Bat is one of those things where if I don't know what a file is, like cat is for when I know what's in the file. Bat is for when I'm interactive and I don't know what's inside it, because bat is really good about not doing binary files, which is super nice. So yeah, bat is super nice. The way it does like syntax highlighting stuff, it's a great tool. I love these new modern tools that exist. They're wonderful. So what do we have here? We read in the entire line. Now we have a line of this stuff. So we have to go through each character in this line and put it into a grid. So we will make a 2D grid system. And in Bash, we're just basically going to make an associative array. And we will call this antennas. This will be where all the antennas are. Let me think about how to do this. This is going to be tough because we might... I'm trying to think of how to store this. Ideally, I would reach for a hash map within a hash map. I would have the name of the antenna, like A or B or C, and then I would have all the locations that it shows up. In Bash, we don't have that two-dimensional style arrays, so we'll have to come up with some sort of way of doing this. There are ways. I'm just trying to think of the best way. So let me think about how we want to actually store where the antennas are. I think we'll have to push onto a string. I think that's what we'll have to do. Let's declare these. Every time we get to a bottom of a line, then the height plus plus. And the width will equal the length of the line. We will overwrite this every time we parse a line, but we should assume that the every line is the same width. I'm going to make that assumption. So this looks good. Now we have this line, so we have to read this line character by character, and we have to put them into a nice little two-dimensional array of all the antennas. So let me think. Let me think about how we want to store this data. Loop each character. We can just do a for I equals 0, I less than, let's do this up here. Width, I plus plus, do, done. Call this X. We'll stay away from I and J. We'll use X and Y when we're dealing with coordinates. I think that's the safest way. So we have width and we have X for height. We need to check if it's something we care about. And the easiest way here is antennas were lowercase, uppercase, and numbers. Probably just do a regex, honestly. I think I could do a case statement where I could say like, Is there a way to do that? There probably is a way to do like a range like that. But let's just do a nice little regex. We'll just do antenna regex. And an antenna regex would look like 0 through 9, A through Z, A through Z. And that'll only just appear once. That's not right. No, hold on. My regex lack of skills is showing. That's what I wanted. So yeah, we'll just use this to search for if the character, first let's grab the character. The character at this location is the line substring of X to 1. So we're going to grab the character that's at spot X in the line, and we're only going to grab one part from that. We're making a substring basically in a substring of 1, so we have a character. If C is a regex match for antenna regex, then we found an antenna. Hey, look at that. So if we found an antenna, we can make a key for this, and the key will be the X comma Y coordinate. We have the X, and the Y coordinate is actually just the height. So we have our key, and then we can say antennas key equals the character. So we can keep track of which antenna is actually there. So now we've gone through and we've figured out where all the antennas are. So let's go ahead and just print this for now. So we can do for key in antennas do done value equals this. I have a function to nicely print an array that I've had for over a decade now. I should just bring that in here. It's so useful. Echo. There we go. Okay, so we found all the antennas. Is that correct? It looks like there's 4 0 antennas and 3 A antennas. That looks correct to me. Okay. So what we could do now... Yeah, we're going to want to... I know what we're going to do. I know what we're going to do. It's not the most efficient. I would store it backwards, but we're going to reverse the storing. So we're going to have a key of the letter A, which is antenna, and it's going to be an array of all the spots that it shows up. But we'll process it in the loop so we don't have to store that array anywhere. So we get around the 2-dimensional array requirement. So here we go. Let's see. You know what? I am going to do that thing that I said I was going to do. I have this function that I've carried around with me forever. I think it came from the Bash wiki called PARR, print array. And all it does is you give it the name of an array, not sort of any sort of expansion. You give it the name of an array. It does autocomplete too, which is really nice. And it will pretty print it like this. You cannot read this back into your shell. This is not safe for parsing. This is just meant for human consumption, the same way var dump in PHP or like util.inspect in Node would be. But yeah, I got this from the Bash wiki. It was like one of the only legitimate use cases for eval I've ever seen, because there's no good way to really indirect a sparse array. Bash can have sparse arrays where, you know, it's like array spot 0, array spot 1, array spot 7, where there's 3 elements, but the numbers are different. So that's technically an indexed array, but it's sparse. And if you use like indirection or name references, they don't quite work the way you want to. They might work better now. This was 10 years ago when I got this. But we're just going to take this function. That's formatted ugly. Let me take this function from my vimrc and just straight up put it in here. Not my vimrc. I'm an idiot. My bashrc. Where's PR? Where's that defined? Oh, is that in my... Oh, God. I'm way too extra. I wrote my own like interactive Bash plugin manager thing, and all it has done is made things so much more convoluted than they need to be. Did I put in Bash interactivity? Oh, I'm so much. Oh hey, wow. I write good comments. Let's take this. Why am I highlighting it with the mouse? That was the only file to edit? What am I, stupid? Oh my god. This is a mess. Yeah, so this simple function that I'm pulling from my bash RC, really nothing special. It just allows me to print an array. Actually, yeah, you know what? Let's put it in its own file. We'll put its own file. It's away from the world now. Actually, no, we don't need to do that. And then we can just source it. So we can just source. Now we'll have access to that function, so we can just run that. And the reason I'm doing that is because now I can just say PR antennas. Like literally I can just do that. And now when we run it, we'll get that output. A little bit nicer. That's all I'm really doing with that. So, where are we doing now? This is read in the input and find all of the antenna locations. Get a list of all antenna names. So now that we have all of the antenna locations, we should also keep track of the names. Declare -a antenna names and antenna locations. So antenna locations will map the location to the name of the antenna, and antenna name will just say that we found an antenna with that name. That's all we will do. We'll just put a 1 there, some sort of flag. So now we can list over these keys and we have a list of all of the possible antennas we've seen. So I'll show you what that looks like if I print array on both of them. So we have antennas here. Let's do antenna locations. This is what we had before. And antenna names. Yeah, it should have an S. So there you go. You can see that we have all the locations, and then right here, the name 0 and the name A. If we loop over the keys, we get the names of them, and that's what we need. So to calculate antinodes, cool. All the antenna locations and their names. Loop over each antenna name found and calculate their antinodes. Cool. So we will make a map of all the antinodes we find. This again will be XY coordinates of where we found an antinode. The beauty of this is we'll go through like all the A's and calculate their antinodes. If they're within the bounds, we'll store them. Then we'll go through all the zeros, do the same thing. If there's an overlap, doesn't matter. We're just setting a flag that we've already set. So this will help us deduplicate any sort of overlapping antinodes. Antinodes. Said antidotes. So let's do this. Declare -a antinodes. For antenna, this is the name of it, in antenna names. And this will loop, what does this loop by default? The values? Yeah, we need to loop the keys. Do, done, echo, antenna. Let's just run this and make sure everything works. There we go. We're looping over every antenna that we've seen. So now we can process echo calculating antinodes for antenna. There we go. Now we go through and we process, we figure out what the antinodes look like. How are we going to do that? Let's think about what the logic looks like. I already have some theories. I think we're going to have to create every sort of is it every sort of permutation combination? Like I said last time, I get all these words wrong, but I know what we're going to have to do here. So we have 4 antinodes here. Let's go ahead and give those each their own individual index. So this is antinode 1, antinode 2, antinode 3, antinode 4. What we need to do is we need to calculate, antenna 1, antenna 2, antenna 3, antenna 4. Now we need to calculate the antinodes. So we have to check antinodes from 1 to 2, from 1 to 3, from 1 to 4. Then we have to go from 2 to 4, from 2 to 3. Yeah, we have to do every possible arrangement of them. There's a name for this. Is it? I think it's 4C2. Is this 4 choose 2? I'm stretching my math knowledge here. I'm pulling up data from 20 years ago, but I think it's 4 choose 2. How would you do that algorithm in code? I think this is very similar to the logic we did for picking out all the possible operators. Where instead of operators, we have indexes and we have a length of the string. I think that's actually how we do it. Because we basically have to figure out which antennas we're going to calculate the antinodes for. We haven't even got to the part where we're calculating antinodes. We just have to figure out which combination of them. So we basically have to do, let me go ahead and just write this out. Foo.text. If we have antennas 1, 2, 3, 4, we need to check antinodes 1, 2, this. We need to check this, which I think is just 4C2. I think that's all it is. How do we generate this list? What do you actually do? I see exactly what we do. Okay, I see exactly what we do. This is just basic string manipulation. Start at the first character and combine it with every character in the string. Move forward one, combine it with every character in the string. Move forward one, combine it with every character in the string. Okay, that's super easy. Yeah, I'm gonna go forward with this. The way we can do that. Yep. So let's go ahead and figure out how many there are. Oh, wait a minute. Here we go. Here we go. Instead of doing 1 here, we'll just actually do a count. I think this is the way to do it. So we can just do this. Antenna names at C. What do we want? What do we want? What's the syntax for this? Antenna names at C++, right? Do you put this in these? I don't know if that's valid. I'm confusing myself, but let's just do this. I've used the syntax before. My brain's just blanking on it. Yeah, it's a syntax error. I think we don't actually need... I think we just literally don't need this. I think we actually just do this. I think that's valid syntax. Turns out I was wrong. It can't be this. Right? No, that can't be right. All right. I'm going to cheat. And by cheat, I mean... I've done this before. In previous days. Where did I do that? Yeah. Oh, you just don't use the $sign. Okay. I knew I had done that syntax before. I was just confusing myself. There we go. So now, when we print array on it, it should have the count. How many times they showed up. Okay, perfect. So 0 showed up 4 times. A showed up 3 times. Cool. So now in order to calculate the antenna, we'll figure out the count of them is antenna names. And we just need the, we need to just index it at antenna. Antenna names is now poorly named variable. So we should change that to antenna counts. There we go. Let's just double check that this code still works. Okay, cool. We have the count of how many times each antenna shows up. And then we need to calculate antinodes for them. Calculating antinodes for antenna 3. Cool. So we'll give a little bit more verbose. Calculating antinodes for antenna 0, 4 found. Calculating antinodes for A, 3 found. It's a little bit confusing. Sounds like it found 4 antinodes. Antennas found. Cool. So now to do this, the way we're going to do this is we have 4. So we need to check. Let me think about this. We have to find every single combination to check. Okay, I've got it. To do this, we are going to loop over the antenna locations. Sadly, we're going to loop over all of them. this name equals antenna locations, location. Yeah, because these are all of the... If... Okay, here we'll do name equal antenna. We need to make sure they're the same name. Otherwise, continue. Then we'll echo location. So what this should do is it should go through. It found nothing. Cool, we did something wrong. Yeah, that makes sense. That's not the name. That's the coordinates. Yep. Oh, I was right the first time. It gets really confusing when you have to start naming so many different things. If it's not the name we're looking for. Okay, cool. So what's going to happen here is we're going to... Okay, perfect. We are looping over antenna 4. There were 4 antennas found. Here are the coordinates of all 4 antennas. And the beauty of this is we can shove this all into an array, and then we'll have a unique index for each antenna. So index 0 will be this, index 1 will be this, and then we can calculate which ones we need to check in what order. So, it's very convoluted here. Loop all locations found and filter only for the antenna we care about. If we are here, we are processing an antenna we care about. Cool. So what we can do is we can take all these locations and shove them into an array. Cool. So now we have an array of all the locations we need to care about. And the reason this is beneficial is we have the index of them. So what we can do here is we can come up with 2 indexes that we will check. We'll just call them A and B. So A is 0. We're going to start at the 0th index, and we're going to go all the way to the length of the location. We have count. Beautiful. We have count. Let's assert that count equals the length of locations. They should be the same. We should find the amount of locations that match the count, but if we don't, then we'll know something's broken here. We'll exit too. That's just an assertion. This should be the case. Cool. So now down here, for A equals 0, A less than count, A plus plus. So we're looping over the list of locations we found. We're starting at the first one. And now that we're at the first one, we need to loop all of the subsequent ones, but starting 1 index over, and then we get the combination of all of them. For B equals 1, B less than count, B plus plus, do, done. So now we have A and B index. So A location is locations at A. B location is locations at B. And we'll just print out what we're doing here. Echo finding antinodes for A location and B location. If this all works how we expect it to, okay, this looks really, really cool. So we're going to find antinodes for 7, 3, and 4, 4, 7, 3, and 5, 2, 7, 3, and 8, 1. And then we're going to find them for 4, 4, and 4, 4. Okay, this one's wrong. I see what's wrong here. B doesn't start at 1. B needs to start at A plus 1. It needs to start at the next one on the list. That's what needs to happen there. There we go. So yeah, we're going to check 6 different unique locations, and we're going to check 3 different combination, so not unique locations, combination pairs. So we've effectively chose 3. We've created all combinations of 4 into groups of 2. And now we need to figure out the algorithm to calculate the antinodes. Oh my God. Okay. So I'm just going to go ahead and do this in a function. Yeah, that's what I'm going to do. Find antinodes given a B and given an A and B location pair. Cool. Find antinodes. Cool. We'll just pass them as arguments. So basically what we'll do is when we get here, we'll just do find antinodes A location, B location. Cool. That's all we will do. And now we will figure out what this logic actually looks like. So in order to find the antinodes of two things, we need to come up with a mathematical formula to do this. And I don't think it's going to be difficult, but the first thing we need to do is we need to break A location into B location, which is a number comma number pair. We need to break those into individual numbers. So we need the AX coordinate, we need the BX coordinate, the AY coordinate, and the BY coordinate. And then we need to break these into two different variables. This is really easy. We set the IFS equal to the comma because that's what we're splitting on. Read -r A comma X, A comma Y, and we will read in from the string of A location. And then we'll do the exact same down here, but we'll read into BX, BY using the B location. Now we need to figure out the distance between the X and the Y. So I think probably dx, dy? I don't know, whatever. I'm not good at math, so I'm not good at these variable names. We need dx and dy. So dx is going to be equal to ax minus bx. It doesn't matter which order we do this in. One of them will yield a negative number, one of them will yield a positive number, depending on the order, but it doesn't matter because we are going to get the distance by taking the absolute value. And the way we take the absolute value, which we have done in the past, is we're going to chop off the hyphen if it's there, because strings in Bash, or numbers in Bash, are just strings. We can just treat them like strings, and that's a beautiful thing. Let's document this code. Turn location string like 5, 6 into 5 and 6 for both locations. Calculate the distance between both X and both Y locations. Cool, so now we have the distance between them. Oh boy, we can calculate the antinodes. And the way we calculate the antinodes is by using something. How do we do this? We basically need to take, we're always in the positive direction. Let me think about this logic. Okay, we should be fine. I don't know which direction to go from any one of the antennas, because technically speaking, if we start an antenna, like if we have an antenna here and an antenna here, we jump up here to get the antinode, but we could also jump down here and we could overlap with the antenna. And if we just overlap with the antenna, then we just went the wrong direction, so we throw those out. So we'll have to try 4 directions, I think is what we have to do. Try all possible antinodes. And the way we will do this is we will do local new test antinode equals don't forget these. Test antinode equals ax minus dx comma ay minus dy. Okay, we're getting there. So these are the variables we are going to test. We have to check to make sure they're valid, because we could just write out antinodes that are way off in the weeds if we do it this way. Yeah, that's what I'm worried about. If we do it this way, we're going to write out antinodes that are just absolutely way out in the weeds. So let's go ahead and move this function where we find antinodes. Let's move it down here so we have things, we make sure that we have things like height defined, width defined, declare these, or instantiate those, initialize those. Wow, I used every wrong word. So what we'll do is we will do bounds checking here. And the way we'll do that is we'll do I have an idea. All possible antinodes. Time to lock in all possible antinodes. So we're going to create an array. This should be an array size 4. And all possible locations will look like this. AX minus DX. AY minus DY. BX minus DX. BY minus DY. And then the same exact thing, but with plus signs. There's going to be overlap, but these are all the places that they can be. And then we need to loop them for test location in all possible antinodes do done. So now we have this test location. We need to check if it is in the map, if it is valid. Oh, I have a cheeky way of doing this. I have a super cheeky way of doing this. Where we declare these, let's just declare a third thing called all locations. This is so cheap. And then we can just do all locations key equals 1. So we'll keep track of all the possible locations. The key will be here. So now we know all valid locations are in this array that we've created. So we can do a quick little check if the test location is in the valid location. If -n all locations test location. Yeah, if this is set, then location is valid for an antinode. Record it. That's it. And then I think we declare antinodes. Well, we declare it down here, but we call the function up there. Well, less than ideal, but here we are. Antinodes test location equals 1. There we go. We're just turning that flag on. V. We can do like else true. We'll just put nothing here. Uh-oh, this location is out of bounds. Cool. I think that's all we do. And then when we get all the way to the bottom of this, the count of antinode, I think the count of this will just be the total that we encountered. So we can just say echo created total antinodes. I think that's it. So if we run this, we get command not found. Cool. So we get syntax error. Where do we get syntax error? Line 7. There's just a comma here. Why is there just a comma here? That's awesome. Oh, also, I just made up a variable called all antinodes. Yeah, that makes sense. Created 27 antinodes. So that's incorrect. That is absolutely incorrect. We didn't check. We didn't do checks. That's what we didn't do. We didn't do checks here. Just wait for part 2. I'm always waiting for part 2. I know it's going to hurt. Oh, we didn't do a check. That's what's going on here. We have all these test locations. We only check to see if they're valid. We didn't check to see if there are antennas there. If it's valid, let's think about this. Yeah, I don't know how we're going to do this. Because I'd have to negate my own assumptions here. Let me think about this. Oh, my God, we can just throw them away so easily. Oh my God, we can just throw them away so easily. We just have to filter out. If test location equal B location, or test location equal A location, then continue. Yeah, we're just filtering out if we're trying to overwrite what we already have. Ignore locations that ignore our own locations. Check if we are in bounds. That's it. So now if this works, it should print 14. 22. Not quite right. All right, so my question is, why does it think they're 22? Would it be helpful to print the grid? Yeah, would it be helpful to print the grid and see what we have in a visual sense? I think it might be. Yeah, let's make a function called like print grid. And we have, I think it's all locations. Yeah. So we can do a for x equals 0, x less than width x plus plus, do for y equals 0, y less than height y plus plus, do done, done, key equals x comma y, c equals all locations at key, and then we echo dash n c, and then we put a new line here, and that's all we do. So at the bottom of this, let's go ahead and print grid. So what did I just print here? Well, I printed the graph upside down. Why did I print it upside down? I know why I printed it upside down. It's because the way that we're doing the height. Yeah, we'd have to do the height backwards. That's what's going on. Height minus 1. Yeah. While it's greater than or equal to 0. Yeah. That's what's going on. Cool, so all we do is we print the grid. Let's overlay antinodes on it. So we'll print the grid, and then we'll print an antinode on it. If antinodes key, if this is set, then C is a pound sign, else C is whatever character it was before. Okay, that's a lot of antinodes. And if we look at the example that we have here, it should be this. So this is way off. Is it backwards? It's not even printing right. Let's do this logic for now. It's not even printing correctly. Yeah, this puzzle's backwards. Why is it backwards? What? I thought I fixed that. x comma y. The y is the height because we've just initialized it to 0 and it counts its way up. Yeah, so height goes to the right or height goes down, gets higher and goes down, and width gets, yeah, what is... Well, we got to get print grid working before we can even do anything meaningful here. No. No. Now I'm confusing myself. Okay, well... It doesn't... A's are in the right spot. These zeros are shoved down from where they should be. So let's go ahead and figure out why that is. So if we cat the example and we cat my version, yeah, the A's are in the right spot, but the zeros are moved down. Why might that be? Local x and y. I mean, yeah, and it shouldn't hurt anything. I don't think I'm using those variables for anything else, but I can be good. I don't think this will change anything though. Yeah, it's not gonna change anything. Something's not right here. Yes, the x comma y goes down. This all makes sense. And then when it comes time to print what we have, x equals 0, y equals 0. Yes, that should be at the top. We're doing this little thing, but we're overriding it, so it doesn't matter. All locations is the thing that's getting messed up. I'm gonna have to figure out why this is printing weirdly. Where does it think the 0 should be? 7 comma 3 is a 0. 4 comma 4, 5 comma 2, and 8 comma 1. 8 comma 1, let's look for that one. So that means 8 across, starting at 0, so this will be here, and then 1 will be here. So there should be a 0 there. It's not even right. Neither of the inputs shows that he's 0 there. So what is going on? What am I doing wrong? What's my regex doing? I think the regex was fine. I think we got all the antenna locations right. Yeah, what am I doing wrong? Okay, it's 12 by 12. That's fine. Those look right. All right, read the puzzle data in. Get the width of the line, the first line, and then loop every single character in that line because we have the width of it. Grab the character from that, so like spot 0, grab the first one. Now we have the character, and we have the key. We construct the key by taking the x coordinate and then the y coordinate, which is the height. The height starts at 0 and then works its way up. That makes sense. And we set that character in all locations. That's the only place we modify this variable. Yeah, we declare it up there. We print it down here. That's fine. I don't even think we touched that again. Did we touch it again? Yeah, we just check it here. We don't actually overwrite it anywhere. Yeah, so that variable is loaded up with where all of those things should be. And then we loop over it, and we don't quite get the right puzzle. Actually, you know what? Oh my god, we are getting the right puzzle. We are getting the right puzzle, but it's rotated. It's rotated counterclockwise 90 degrees. We need to rotate it clockwise. We are getting the right puzzle. It's 12 by 12, so it has no problem printing it out. Oh, yeah, so it's just probably the way that I'm printing it. We are storing it x comma y. Let me just do this and then try and understand it first. Okay, that fixes it. That fixes the display bug. Why did it fix the bug? That's what I don't quite understand. Why do we have to put y first here? What did we name incorrectly? Oh my god, yeah. No, this is right. When you're looping over the width of something, we're figuring out the location. No, that's the x-coordinate. That's not right. Yeah, we are figuring out the x-coordinate. I don't understand this, and if I don't understand it, I'm not going to be able to continue with it, so I need to make myself understand before we can make meaningful progress on this. Because as long as we do everything consistently, it should be okay. Something about this line just sticks out to me. I know we put height here, but that's okay. It's got to be the way I'm looping it here. I think we're okay here. I think just because we're looping over every possible x value. Oh yeah, we can't do it this way. We just can't do it this way. This is the printing. This is just the printing logic that's broken. We literally can't do it this way. You have to do all the y's first and then do all the x's within the y's because all the x's are all the characters. That's literally why. That's literally why we can't do it this way. Yeah. Yeah, now we can leave it as XY if we just reverse those. There we go. Yep, okay. I think that was just a display bug. That's all I think it was. That's okay then. So it's just being printed out incorrectly, which means let's start doing this. So that's where it thinks all the antinodes are. That's too many antinodes. There are not that many antinodes. If we look at the original puzzle, we can see that there should be like, it's creating all sorts of antinodes that just should not exist. I'm looking, it's hard to see, I'm comparing the two puzzles. There's just antinodes that are just in weird places. So, okay. We at least have a way to print it now. So we have antinodes that are showing up that just should not be there. Nice. So why is that happening? We have a function called find antinodes, and I think it's just finding too many. So we get the location strings for the A location and the B location. We get the distance between them on an X and Y factor. We get echo for AX and BX. The D of X is D of X. It's going to be a lot of output. Let's go ahead and make sure these look sane. For 7 and 4, the distance is 3. For 3 and 4, the distance is 1. For 7 and 5, the distance is 2. For 3 and 2, the distance is 1. Yeah, these are all right. We're just doing really basic stuff here. There's nothing fancy going on there. Try all possible antinodes. Okay, in order to try the possible antinodes, we take the A location of X and we subtract the distance between A and B. Then we subtract the distance between A and Y. From B, we do the same thing. From A, we do the same thing. And from B, we do the same thing. Echo testing, test location. Okay, it's gonna be a lot of output again. So for antinodes 9 and 9 and 6 and 5, we are checking 6 and 5, which should get thrown out, 9 and 9, which should get thrown out, 3 and 1, and 12 and 13. So we were testing 4 per. If we go down here, it should be 2 per. Give me... No, see, this is wrong. Yeah, 5 and 0. No, wait, 5. No. Yeah, we shouldn't have 5 and 0 here. 0's fine, but it shouldn't be 5. Eight minus 5. And then we did... No, how do we... There's no way we should get 0 here. We should either be getting 1 or we should be getting 3. We shouldn't be getting 2 here. Okay. That won't work. Yeah, something's really weird here. Some of these are throwing out really bogus answers. Finding antinodes for 7, 3, 4, 4. So 7 minus 4 would be 3. And 7, or 7, yes, 3. So we should be checking 10, 7. Let me think. 7 and 4, the difference is 3. Yeah, that's fine. That's fine. So 7 plus 3 would be 10. 4 plus 3 would be 7. How do we get 5? How are we getting 5 when we have 3 and 4? I've got to be storing a variable wrong here. I've got to be using x when I mean y somewhere. It's the only thing I could think of. All right, let's lock in. Find antinodes. We give it the A location and we give it the B location. We get locations at A and locations at B. Yeah, so those are being properly parsed in there. AX, BX, AY, BY. These look good. Just gonna put some debugging in here. Okay. Seven, 3, 8, and 1. Okay, we're properly breaking them down. 8 minus 7 is 1, so if you go 7 down, we get 6. If you go 8 down, we get 7, 8, 9. These all, the x's look fine. All the x values look fine. It's the y values that are gnarly. Because all the possible y values here, they should be negative 1, 1, 3, and 5. Now these all look fine. They're not syncing up correctly, I don't think. How are they not syncing up? Oh, this one's wrong. Because the difference between them is 2. So it should be... No. No, this is right, but we're just not syncing them properly. I know what it is. I know what it is. I know exactly what it is. It's because in order to make y grow, you have to push it down, not up. That's why these are out of sync. So because we have the distance here, we have to reverse these. I think. 22. Still not right. No, that's probably just way wrong now. Bro, I don't know. Something about this that I'm doing wrong. Maybe coming up with an example would be helpful. Yeah, that's way too many. To the point where I don't even know where they're coming from. Let me do this. CP example to simple.txt. Let's make a very simple one. That should be easy enough to calculate where the antinodes are, right? Okay, that looks right. That correctly created the antinodes. Now if we do there should be no antinodes because they both go off the page. Cool. If we put these up here, we've created 2 antinodes. Okay, we're starting to work. Yeah, that one became an antinode. No, that one shouldn't have become an antinode. Also, how would we get one here? Yeah, something here. This is wrong. There shouldn't be this many values to test. There's something wrong with this. Every so often we just test values that are just invalid. Whatever logic we're using to make values is not right. If I just leave those, so those 2 are causing an issue. If I get rid of this one, do we still have an issue? We do. What kind of antinodes are those? We're going in the wrong direction. Huh. Let's see, chat's a little bumping. Absolute values for the DX and DOI will make only northeast and southwest lines, even if the antennas are aligned the other way, I think. Maybe I should have read your message earlier. I wonder if that's what I'm dealing with. I've definitely, by taking absolute value, I think you're right. I think I am losing some directionality here. I wonder if it's literally just the absolute value that's causing the problem. Because then I align them to an axis that I didn't mean to. That's totally a thing, because I'm plus and minusing them, so it actually doesn't matter. They should get sorted out. Yeah, DMS 37. I should have read your message sooner. Oh my god, you think you're onto something. I think this is it. Yeah, you're totally right. Now that I think about it, you would align them to, you would force them to be one direction. I don't know why I did that, because I was already checking all possibilities. I tried to deal with this problem, and then I dealt with it again. And when you get into that situation where you deal with something twice, you undo it and you cause weird cascading effects. So I think this is, that looks way better. Yeah, I think that's what it was. Good call. Good call. Oh man, DMS 37. I have no idea if you're still here. Sorry for ignoring your message. Yeah, 14 antinodes. That's what it was. That's totally what it was. It was the absolute value that broke everything. It was absolutely the absolute value that broke everything. Oh my goodness. I wish I had read your message sooner. There are 14 total unique locations, and when we run this, we get 14. So, yeah. I am. Matt to the rescue. Thank you. I appreciate it. I'm a sysadmin who pretends to be a programmer, and one of my biggest weaknesses is my math. If I could just learn more. Let me take that back. If I could just learn, I should spend more time learning math so I could get better at calculations like this, because I end up just confusing myself and it's just no good. I create really fun bugs, but yeah. So let's go ahead and run it on the real input. Created 220 antinodes. That was super fast, wasn't it? Think it's gonna work? That's the right answer. You are 1 gold star closer to finding the chief historian. Let's go. Let's go. Thank you so much, DMS. You are the MVP for tonight. Part 2. Watching over your shoulder as you work, one of the historians asks if you took the effects of resonant harmonics into your calculations. The answer is no. I didn't. Whoops. After updating your model, it turns out that an antinode occurs at any grid position exactly in line with at least 2 antennas of the same frequency. What? Regardless of distance. This means that some of the new antinodes will occur at the position of each antenna, unless that antenna is the only one of its frequency. I don't even understand what this means. So, these 3 T frequency antennas now create many antinodes. Oh, you gotta just keep going? Oh my god. Oh, we're gonna just raycast out this frequency. In fact, the 3 T frequency antennas are all exactly in line with 2 antennas, so they are all also antinodes. This brings the total number of antinodes in the above example to 9. Hey, well that answers my first question. What? How are there 9? In fact, the 3 T frequency antennas are all exactly in line with 2 antennas. So they are all also antinodes. This brings the total number of antinodes in the above example to 9. Okay, I see 10 marks. No, 9 marks, 9 marks. So every single one is also itself an antinode. No, I'm so confused. Wouldn't all antennas be antinodes? Because wouldn't they be in line? What am I missing here? Any 2 antennas would also be in line with each other. Including the antennas that appear on every antenna. Yeah, every antenna should also be an antinode, right? Oh, okay. So the antennas with antinodes are also antinodes. Okay. It seems like any antenna is also an antinode. Would we even have one that's not an antinode? Unless there's only one that frequency. Okay. Yeah, you're right. Yeah. Because it needs to actually, in order to create an antinode, you need at least 2 antennas. Okay. Every single part 2 has made me feel like this, where I go, this is going to be impossible. Wait, no, this is going to be easy. Wait, this is going to be hard again. Okay, let's just jump into it. Every single part 2 has made me feel that way. Also, what's up, Aneurysm? Welcome. Part 1. Part 2. Okay, part 2. Let's go ahead and see what we are working with. So our find antinodes logic will have to be updated. Let's get rid of these lines. I never want to see them again. They cost me about like an hour worth of debugging. So these are all possible antinodes, and we... Oh, so this will have to change. We don't care if we're at our own location, because if there's more than one... Yeah, we never did an early escape here. I actually don't know how this worked, I'm going to be honest. But we never did, like, you know, count greater than or equal to 2. We never checked that there's at least 2 antennas. We'll put that here. But yeah, like, just skip this antenna if there's only one found. We didn't have that, but I'm assuming some sort of default behavior saved us. That's part one's problem. So here's where we test all possible ones. Look, I even had this question up here. Can antinodes created by frequency A overlap with antennas of the same frequency? Well, the answer is, LOL, yes, they can. Wait for part 2. LMFAO. Cool. So now, ignore our own locations. Yeah, we don't need to ignore our own locations. Yep, we do not need to ignore our own locations. So now, how do we make it constantly keep going out? Let me think about what this logic will look like. I know what this logic looks like. We make an array, and then we programmatically push into this array instead of having a constant. We'll do it twice. I'm going to think about this, I'm going to write it out, and then we'll think about it. I always start with, the way I program is I start with an infinite loop, and then I come up with my condition to break, and then I'll rework it if it makes sense. While true, let's do all possible antinodes plus equal, and we will add things to this list. And what do we add to it? We will add these two. This can't be right. Okay, this is valid syntax. I know for a fact this is valid syntax. I don't know what it's yelling at me about. Yeah, we'll do... I'm just going to make up some stuff. New x equals ax. New y equals ay. While true, we will add the new x, the new y, yeah, hold on, we got this. Oh yeah, we got this. We'll add that coordinate, and then we'll do new x plus equal the change in x. And then we'll do new y plus equal the change in y. And then we will check if we are in bound here. That's what we will do. This is our bounds checking thing. Okay. So these are all possible antinodes. Check if we're in bounds. If we're not in bounds, then we break. Okay. Code's a little bit scuffed right now, but bear with me. This is the key. All possible antinodes will push the key onto... I think we can actually skip all this logic. I think we can just add the antinode directly. Yeah, I'm going to go ahead and do that. There's going to be some overwriting, but it doesn't matter. There we go. Yeah, okay, perfect. Oh, we're getting there. We're getting there. We make a new key. Skip all locations key. While... No, I'm just gonna leave it in the while loop for now. Let's make sure we have it working. If it doesn't exist, then we break out of this loop. Otherwise, we set this new key to an antinode, and then we increment it by our change in x and y, and we keep doing that until we go out of bounds. And then we do the exact same thing. Copying and pasting code is always good. And we do this, but we minus equal. I think we have to test both. I'm not above duplicating the same code 4 times. I am absolutely not above doing that. There's going to be such a cleaner way of doing this, but I don't care. I just want to get this done to make sure that my logic makes sense. So that's all the A's and that's all the B's. This is all the A's and all the B's, and we're going to go minus instead of plus. Guys, this sucks. Yo, what's up, Steven? How you doing? All right, part 2 with simple. Here's what simple looks like. Guys, I think it already works. Like, that looks good. It's a lot of printing there. Here, let's use the example. Let's do part 2 with the example input. That's what the final puzzle looks like. And then we'll do cat the example input. And it looks like we're spraying out in the right direction. We created 34 antinodes. I actually don't remember what this is. The original example now has 34 antinodes. Listen, sometimes you just gotta duplicate code 4 times. This is what I was saying earlier. This is where math knowledge would help me. Given time, I could refactor this all into... Oh, that was wild. I could refactor this all into, like, you know, one function or whatever with just like a direction type of thing. But I don't feel like doing that now because we're going to get the answer. So let's go ahead and run part 2 with the real input. Oh, you can't see my terminal. That would have been anticlimactic. Let's go ahead and run part 2 with the real input. You guys ready for this? Oh boy. 813 antinodes. Let's just appreciate how much faster this runs than some of the previous puzzles. 813. Let's go over here. And why is there a scroll bar down there? Let's just, there we go. 813. You guys ready? That's the right answer. You are 1 gold star closer to finding the chief historian. You have completed day 8. Let's go. Let's go. All you got to do is duplicate some code. And actually, at the end of the day, I feel like because the way I implemented it, which was not fantastic, I think because of that way, it was actually easier to do part 2. Because I just kind of had to keep, like, I was more or less just keep going, keep trying. We already had that distance, so just keep going. Nice. Yes. Woot. Yeah, we did it. Nailed it. Nailed it. Day 8 is done. Oh, man. Thank you for tuning in, everyone. And look at that. An hour and a half. Not too bad. Not too shabby.